Okay, my dear students, in the previous lecture, I have gone for the optimality test of the transportation problem. Here we have seen that how we will find out the solution of a transportation problem by the Vogel's approximation method, and after that, how the optimality test will be done by the Modi method. So in the previous problem I have chosen, we have seen that in the first step, means after getting the initial basic feasible solution, when we gone for the optimality test, we have seen in the first step we got the all delta ij is greater than 0, which indicates us that the initial basic feasible solution was the optimum solution as well as unique solution. Now in this series, lecture series, I will choose some problem where we can see that the another two cases, means at least all delta ij greater than 0, but at least one delta ij is equals to 0. So in this scenario, the transportation problem has more than one solution. So this situation we will consider here, and we will find out that another solution also. The third case was if any of the delta ij is less than 0, then what would happen? So in these two cases, the procedure is same. So in this lecture, we will considering these two type of situations, the two cases. Now, in these two cases, we need the concept of the loop in a transportation problem. So loop is nothing but an order set of 4 or more cells in the transportation table, which will form a loop if and only if any two adjacent locations lie either in the same row or in the same column. Secondly, any three or more allocations do not lie in the same row or in the same column. So these two different situations will get. So you can see the figure here. So basically, after here you can see that this is origin 1, origin 2, origin 3, origin 4, origin 5. This is destination 1, 2, 3, 4, and D5. So basically, this is a 5 cross 5 order matrix. So after the allocation, you will get total number of allocation is nothing but 5 plus 5 minus 1. Means total 9 allocations you will get. But others means in these cases, here is 25 cell. So 9 allocation is done. So non-occupied cells are also present here, and you have done the optimality test. And let us assume that you got here the negative cell evaluation. So as you got the negative cell evaluation in this cell, and there is the allocation in these cells. So at that time, these type of formation will form to allocate some element here. If this is not possible, then this type of also loop will form. So what is the, maybe the allocation is needed here, and the allocated cells present in this situation or in these places. So it will also, you can see here that this is the second case where that the allocation do not lie in the same row or in the same column. You can see here that in this column there is allocation, but there is no allocation to form a loop with this. So in this case, we have to go through in this way. So that is why the some properties of loops will given here, that the number of cell in the loop must be even. The two adjacent side of a loop are orthogonal to each other. Means you cannot go through this in this way. Your direction either in this way or in this way. Your direction will be either in this way or in this way, not in this way. Means the orthogonal way you will approach, and the loop is direct. Means if you start from here, so this to this, then this to this, then this to this, then this to this, and then you will reach here. If you start from here, then this direction will just change. Okay, so that thing we will also discuss when we are going to solve the problems also. So let us see one problem where we are facing these type of situations. So this is our example number 1. We have to solve this transportation problem and check the optimal. So as you know already that first you will check whether this transportation problem is balanced or not. So you have checked that it is the balanced transportation problem. Now we applied the Vogel's approximation method to find out the initial basic physical solution. So in this case, the initial basic physical solution I have given here. You can check it out by doing it yourself. Okay. Now, see here, after doing this allocation, you can see that the number of allocated cell is nothing but 1, 2, 3, 4, 5, 6. In this case, the origins are 3 origins. So M is equals to 3. M is equals to 3. N is equals to 4. So obviously, M plus N minus 1 is equal to also 6. So these two are same. Means it indicates that this transportation problem has degenerate solution. Now, to check that whether this initial basic physical solution is optimum or not, so we are going for the optimality test, which is called the UV method, which is depending on the Modi method basically. So so already you have seen here that in this particular problem, that in this row, the maximum allocation is 3. No, this row contain 2 allocation, this row contain 1, this column 1, this column 2, this column 2, this column 1. But this row contain 3 allocation. So as I said earlier, that we, after defining the dual variable for the origins, which are U1, U2, U3, and for destinations V1, V2, V3, V4. So we are getting a relation for the allocated cell, that Ui plus Vj is equal to Cij for the allocated cells. So You can see from here that these relations will occur is nothing but U1 these relations will occur U1 plus V2, U1 plus V1, this will be 1, U1 plus V3, this is equals to 1. So first relation will be what? U1 plus V1, this is equals to 1. Second relation will be U1 plus V3, this is equals to 1. Then U2 plus V2 is equals to 3. U2 plus V3 is equals to 2. U2 plus V4 is equals to 1. And lastly, you are getting that U3 plus V2 is equals to, so 3, 3, 6. So total 6 equation you are getting. And as I said earlier that in this case, basically we are choosing U2 is equals to 0. If you put U2 is equals to 0, then from these relations, this one, this one, and this one, you are getting what? You are getting V2 is equals to 3, V3 is equals to 2, and V4 is equals to 1. Then using this one and this one, you are getting U1 equal to minus 1. Then using this and this, you are getting V1 is equals to 2. Similarly, using this and this, you are finding out U3 is equals to minus 1. So after doing this, as you know that how we will calculate delta Ij. So delta Ij is nothing but our Cij minus Ui plus Bj. So for the non-allocated cell, we are calculating all these values. So you are calculating this value will become 0, this is 4, this is 1, this is 3, this is 4, and this is 9. So in this particular table, table number 2 shows what? That all delta Ij is greater than or equals to 0. Be careful, greater than or equals to 0. So the solution is optimum, but not unique, as delta 1 delta Ij is equals to 0. So this situation shows us that this transportation problem has an alternative solution. So in this case, there will be some allocation in the cell number 1, 2. Means there will be the allocation now. So the challenge is how we will find out the loop and how we will find out the solution. So you can see here that in this particular problem, 1, 2 cell, 1, 3 cell, 2, 2 cell, and 2, 3 cell will form a loop. You can see from here. So let us direct it by this. So here will be these 3 cells is loop forming loop with this cell. Now, what will be the amount here? So, if the amount is epsilon here, then this will be 20 minus epsilon. This will be 20 plus epsilon. This will be 10 minus epsilon. Okay. Now, in this case, what will be the value of epsilon? Basically, you will choose those cell containing minus epsilon term. So here you can see 20 minus epsilon and 10 minus epsilon are the two cell containing minus epsilon. So in this case, the value of epsilon will become minimum of 10 comma 20, which is equals to 10. So the new allocation here it will be 10 that I have written here. Here it is 20 minus 10 means tens that I have written here. Here 20 plus 10 means 30. So that I have written here. And here 10 minus 10 means 0. So there will be no allocation. Be careful after finding out these new allocation. Once again, you have to go for the optimality test. Without doing this, you can't say that whatever the solution you got, that is optimal. So the second time optimality test we are doing in the same manner that the U1, U2, U3 are the dual variable of the origin 1, 2, 3. V1, V2, V3, V4 are the dual variable of the destinations D1, D2, D3 and D4. Who is satisfying the condition Ui plus Vj is equals to Cij for the allocated cells. So you will get another set of equations like this. So when you are getting these, let us do in another page, it will be more better for us. So we are here now to find out. So already I have shown in this cell that how the allocation has been done. So how we are calculating this, that once again you can see that in this situation basically you are getting U1 plus V1. This is equals to 1. U1 plus V2 is equals to 2. U2 plus V2 is equals to 3. U2 plus V3 is equals to 2, U2 plus V4 is equals to 1, and U3 plus V2 is equals to 2. So once again, you can see that maximum allocation is in this cell, in this row, or you can consider in this one also. Okay, but for our convenience, I have chosen here this. So this becomes 1, this becomes 2, this becomes 3, using these three relations. Next, as you find already got V4, V3, V2. So using this relation, you are getting U3. As you find out V2, then using this relation, you are able to find out U1. And as you are able to find out U1, then using this relation, you are able to find out. So V1, V2, V3, V4, U1, U2, U3, U4, all has been find out. And once again, the Cij, sorry, delta Ij is equal to Cij minus Ui plus Vj, which is called the cell evaluation, is all find out in this way. And that value I have put in here. This is 0, this is 4, this is 1, this is 3, this is 4, this is 9. So here also you can see that all delta Ij is greater than equals to 0. So the solution is optimum. It is not unique due to delta 1, 3 is equals to 0. That will happen because of initially del 1, 3 cell contain 10 unit, but we are transforming this unit here due to the delta Ij equals to 0. That is why in the next stage, there you are getting 0. So there is no other way. So ultimately, the two solution you are getting from the first one, from here, you are getting the solution as, if I write down the solution, you will get x11 is equals to 20, x13 this is equals to 10, x22 is equals to 20, x23 is equals to 20, x24 is equals to 10, and x32 is equals to 20. And the total transportation cost you will consider, if you find out, the transportation cost will be 1/8. Okay. Now, in this case, when you are considering as you got the new set of solution, what will be the new set of solution? In this case, x11 is equals to 20, x12 is equals to 10, x22 is equals to 10, x23 is equals to 30, x24 is equals to 10, and x32 is equals to 20. Once again, if you calculate the transportation cost, you will see this is also 1. So in the both solution giving you the minimum transportation cost, which is nothing but our 1. Okay. So this is the way to find out the solution, or the another solution Obviously, the optimality test you are doing, but in the optimality test, you are getting one delta ij is equals to 0 and others all are greater than 0. In this situation, the transportation problem has another optimum solution, and the technique to find out we have illustrated. Basically, the loop formation will be done in the case of when any one of the delta ij is less than 0, the same procedure will follow. So let's check it out that what will happen if this situation occur. So I have chosen the second example of this transportation problem. Okay, so first we check the balance or not. Yes, it is balanced. So we apply our Vogel's approximation method to find out the initial basic feasible solution. So we have find out the initial basic feasible solution. You can do it yourself to find out that whatever the solution we got, this is correct. Okay, now see here. After getting this initial solution, what is the number of allocated cell? 1, 2, 3, 4, 5, 6. So number of allocated cells is equal to 6, and which is equals to nothing but m plus n minus 1. Here m is equals to 3, n equals to 4. So yes, it is satisfied. Now we are going for the optimality test. So we are basically defining the dual variable for the origin one, u1, u2, u3. For the dual variable for destination is nothing but v1, v2, v3, and v4. So from here you can see that this row has two allocation, this has two, this has two, this column has one, this column has one, third column has one, fourth column has three allocations. So maximum allocation occurs at D4 or the fourth column. So corresponding to this, the dual variable we have chosen as 0. So after choosing this, as you know that ui plus vj is equals to cij. So from here you can write down the relations. So as v4 equals to 0, you will get u1 equals to 10, u2 equal to 60, u3 equals to 20. Now using this and this cell, you are getting, this is nothing but 9, because 10 plus 9 will be 19. Using this and this cell, you are getting that u3 v3 equals to minus 20. Using this and this cell, you are getting v2 equal to what? Minus 12. So you are able to find out all ui and vj, and after that we are calculating delta ij, which is nothing but cij minus ui plus vj. So you can see that 10 plus minus 12 is minus 2. So 20 plus 2 will be 22. So in this manner, the all cell evaluation has been done for the non-allocated cells. We are not calculating the cell evaluation for the allocated cell, because if you calculate this, you will see that the cell evaluation for the allocated cell will be 0. No question about that. Okay, so here the cell evaluation for the non-allocated cell you have calculated, and you observe that here is the place, or in this cell the cell evaluation is negative. So here one negative cell evaluation is there. If there is more than one negative cell evaluation, then choose the most negative one. Here only one negative, so we have to choose this cell, and here will be the allocation. So I have mentioned here that here will be the allocation. Now, who will or which cell will form the loop with this cell? So you can see that this one, this one, this one, and this one will form the loop. So that's why I have mentioned here. So if there is the epsilon is the allocation, then to balance this, it will be 2 minus epsilon. To balance this, it will be 8 minus epsilon. And to balance each and everything, it will be 10 plus epsilon. So what will be the value of epsilon? I already mentioned, choose the minus epsilon terms. So you are getting that 2 and 8. So epsilon will be what? Minimum of 2 and 8. This is 2. So all other allocation will be as it is. Only these 4 cells will give you a new type of allocation. So what you are getting here? You are getting here that the allocation will be in this way. Okay, just a minute. Okay, there is some problem in this data. So I am basically discarding this data and we are doing this phrase. Okay, so let us see what the allocation we have done, and we'll going for the next page for the. Okay, so this is Control C, and in the next page, Control. Okay, so we have seen that this is the negative allocation. So here will be the allocation. We will do the allocation here. So as we discussed that there will be 2 unit of allocation. So you are getting here, you can see now. So O1, O2, O3, D1, D2, D3, and D4. So this is 19, 20, 50, 10, 70, 30, 40, 60, 40, 8, 70, and 20. The new allocation, as you have seen that there will be a allocation of 2 unit. So this allocation will be not there. This is your 6 unit and this is your 12 unit. And all other allocation will be as it is. So this is 5, this is 2, this is your 7, and as it is. Now you can check it out. What was the available amount? 7, 9, 18. 7, 9, 18. You can see demand 5, 8, 7, 14. 5, 8, 7, 14. Done. So now we are finding out UI and PJ. So U1, U2, U3. Here it is V1, V2, V3, and V4. So you can see that this row has 2 allocation, 2 allocation, 2 allocation. one allocation, two allocation, one allocation, two allocation. So maximum allocation is 2 present in several row or several column. So let us choose this is equals to 0. So obviously this will be our 10. This will be our 19. As this is 10, so you are able to find out U3 must be equals to 10 because U3 plus V4 is equals to 20. It will be as it is 10. So this will be nothing but our minus 2. As it is minus 2, so by this relation, you are getting this is equals to 32. As this is 32, by this relation, you will get this is 8. So you are able to calculate the all UI and Vj. Now we are going for the cell evaluation for each non-allocated cell. So what will be these values? So these values we are getting minus 2 plus 0 is minus 2. So 20 plus 2 is 20. This is 8. 8 plus 0 is 8. So 50 minus 8 is 40. 19 plus 32 means 40, 51. 70 minus 51, it will be 19. This plus 10 plus 32 will be 42. 60 minus 42 will give you 18. 19 plus 10 is 29. 40 minus 29 will be what? 40 minus 29 will be 11. And 10 plus 8 is 18. So 70 minus 18, it will be what? 252. So now you can see from here that all delta ij is greater than 0, implying. So I will erase this one, otherwise it looks like that equals to 0. Okay. So all delta ij is greater than 0 implies the solution is optimum and unique. So as it is optimum and unique, so what is the solution? Solution will be x11 is equals to 5, x14 is equals to 2, x22 is equals to 2, x23 is equals to 7, x32 is equal to 6, and x34 is equals to 12. And just calculating, you are able to find out the transportation cost. Okay, so this is the way to find out the solution when you will get that at least one delta ij is less than 0. Okay, so this is the way to find out the solution of a transportation problem. I have considered all the 3 cases when all delta is greater than 0. You are getting in the first step. Secondly, when all delta is greater than 0, but one delta is equals to 0, then what will happen? And if any one of the delta is less than 0, then what will happen? So these are the all about of the optimality test of the transportation problem. I hope this lecture will help you for the modification as well as your enhancing your ideas. Thank you. Thank you, everyone.